In this video, I'll be trying to solve a physics test question on vectors. The question here says the resultant R of two vectors P and Q is 260 meter per second. If P is equal to 80 meter per second and the angle between P and Q is 50 degrees, find I, the magnitude of Q, II, the angle between P and R. Okay, all right, let's solve this question. Solution. So we'll take down the solution of this question. Solution. Okay, first things first, as usual, let's list out given parameters. So in this question, what and what are we given? The first thing we are given here, they said the resultant of two vectors P and Q is 260 meter per second. So given, the first thing I'm given there is the resultant. So given, let's take number 1 there. Resultant, that's R as equal to 260 meters per second. Right, just show direction here. So we have this. All right. Okay, so what's the next thing that they said? If P is equal to 80 meter per second, number 2, I'm given P this as equal to 80 meters per second. They said, and the angle between P and Q is 50 degrees. Let's call that angle theta. So theta, that's angle between P and Q, is equal to 50 degrees. We have this. We are asked to find the magnitude of Q, right? So Q, we asked to find Q. Let me call this 4. So for Q, the vector Q is equal to what? What's the magnitude? What's the numerical value? So when they say you find the magnitude, they mean find the numerical value, that's all. Now to solve this question, our first task would be to use a diagram to explain this, okay? A diagram would help you solve this better. So let's draw a diagram. What diagram exactly? Now for this question, they said the angle between P and Q was given as 50 degrees. So my first task is to draw an angle of 50 degrees and then input P and Q. So let's call this Q this way. So angle Q, or Q this way. Let's have P going this way. So I have P going this way. Let me extend Q a bit. Let me extend Q a bit to this part here. This way. All right. So let's call this P, right? P this way. P as being equal to, the value for P was given as 80 meter per second. That's 80 in meters per second. So we have this. Okay. Next up, you now have this part here. This is the part where you have. Next up, you now have this part here. All right. So here's where you have your Q. Okay, for Q, it's equal to, we have unknown, and the angle between P and Q, we said is what? 50 degrees. So this angle here between P and Q, theta, was given as 50 degrees. All right, so we have this question here. Now to solve this question, we need to use a law called parallelogram law of vectors. Okay, parallelogram's law of vectors, we've treated that in our previous class. So if you missed our previous class on parallelogram's law of vectors, I'll leave a link to that class in video description. All right, so check the video description. You see a link to get the full class on parallelogram's law of vectors. Now, if you want to use parallelogram's law of vectors, our task would be to convert this particular figure here to a parallelogram. And how do we do that? First things first, we'd have to extend this way. Excuse me. We'll have to extend this way, like this. All right, extend this just to complete this, and then we can take, let's see, is this parallel enough? Okay, this would work. All right, I'll just come here, just erase some part of it so it will look like a good parallelogram. So this one is just an extension from the major figure. I'll do the same thing here. Just come here, draw a straight line to this point, and then I'll try to take up some paths to keep this as a. You could use your normal line if you want to, but for me, I'm trying to differentiate between the original one and the extended. So I will have something like this. So as you can see now, we have a parallelogram here. All right, that's the first task. Next up, from parallelogram's law of vectors, we said that for us to get resultant, the resultant will run from the point of intersection between the two vectors. Now, the vectors P, that's this, and Q, that's this, meets up at this point. This is the point here. Let me call it this side here, or let me give it a label as A. Meet at A. So A here becomes the intersection or the point of meet between vector P and Q. So what do we do? How does this involve, or how do we use this concept in calculation? This point of intersection will draw a straight line from here till the other side. That's this. So we'll now have this. Okay. Now this line here gives us our resultants. This is a diagrammatic expression or explanation of parallelogram's law of vectors. Now note that this part P here on the left hand side is parallel to this part P on the right hand side. So we can still call this P. In essence, we can still call this part, I'll now make this a full line. We can still call this P. That means I can bring P here. I can bring this as P this way, as being equal to 80 meter per second. At this point, I now have a parallelogram that looks like this. So I'll just redraw the full parallelograms diagram, or I now have a triangle here. So at this point now, I now have a triangle that looks like this from here. You can see this triangle that goes this way, that's Q, then R this way, and then P this way. This is a triangle. All right, so I'll just pick out the triangle and draw it out on its own. So let's start with Q. We had Q, let me see this. Okay, we had Q running from this particular line, this one here. So we have Q running this way. So Q is going this way. Okay, this is Q, excuse me, this is Q going this way here. Then R is going this way too. So we have R going this way, that's this, and then we now have P being slanted this way. All right, so what we have here is just this same diagram. Okay, what we have this as Q, this Q here, value is equal to unknown. Okay, and we had that Q was going this way. We have P this way here. We have P, whose value was given to us as 80 in meter per second, as given in the question. Also, we now have R this way here. So you can see R. All right, so we now have R here too. This becomes the R. All right, and this R is equal to, the value was given as 260 in meters per second. So we have this. All right, so we now have this figure. Now let's get some of the angles we can find for this triangle. Now looking at this triangle here, recall that this part here is 50 degrees. That's this point A. The angle here is 50 degrees. If this is 50, we have that opposite angles are equal. So this other angle here at the far top right here would also be 50 degrees. All right, so that means if I combine the angle at A, let's call this point B. Okay, let's call this point here C, that's top left. Let's call this point D. Now having that A and B are opposite, and hence having the same angle as 50 and 50, it means that the angle for C, that's let's call this X, and angle for D, let's also call this X, have to be equal. Again, they are opposite angles. As you can see, they are opposite, so they have to be equal. And if they are equal, this is just simple geometry. It means that the angle at A, 50 degrees, plus the angle at B, which you can see here as being 50 degrees, so plus another 50 degrees. So this plus 50 degrees plus the angle at C, which is unknown, we're calling it X, so plus X, then plus the angle at D here, which is also X. This is equal to, if you know the sum of angles for a quadrilateral, that's for its four-sided polygon, it's equal to 360 degrees. Okay, now combining this, 50 plus 50 we have 100, plus X we have 2X is equal to 360 degrees. So 2X will be equal to 360 degrees minus, I'm moving 100 degrees over here, becomes minus 100 degrees. So 2x will now be equal to 360 minus 100 degrees. And if I subtract that, what I'll have here, my answer would be 260 degrees. So I have this as 260 degrees. To get the value of x, I'll divide here and divide here by 2, also by 2. This cancels this. So x is now equal to 260 all over 2. That's equal to 130 degrees. So I have this. All right, so that means this x value here, this angle here, this one here is 130 degrees. Also, this angle is 130 degrees. Okay, now bringing this value here, right, bringing this 130 to our main triangle here is equal to what there, 130 degrees. In essence, what we have here is not a right angle triangle. All right, it's not a right angle triangle. We have to find the value of q here. What do we use? We'd have to use the parallelogram's law of vectors. All right, and from that we know that all right, so at this point here, for us to get the value of q, we can't use SOHCAHTOA here because it's not a right angle triangle. So what we can use here is the cosine rule. From cosine rule, we know that r squared, this squared, is equal to p squared, that's this, let me write it properly. It's equal to vector p squared plus vector q squared minus 2 into the value of p multiplied by the value of q, then cos theta, right? This cos of theta, let's call this phi or theta, whichever one, or cos of the angle. The angle here, phi, is simply the angle facing the arrow, which in this case is 130 degrees. So phi is equal to 130 degrees. Why? That's the angle facing directly opposite the value of r. Okay. All right, so we have these figures here. Let's put in values. What's the value of r again? If you go back to the question there, r is 260. So this becomes 260 squared is equal to p squared. What's the value of p? P is equal to 80. So it becomes 80 squared plus q is unknown. We'll call this q all squared minus 2 into p. Again, p is 80 into q. Q is still unknown. So this into cosine, that's cos of the angle facing phi, the angle facing, sorry, cos of the angle facing r, which is phi, that's 130 degrees. So I have this as 130 in degrees. Let's put in values. From here, 260 squared, the value there is 67,600. I have this as 67. If you punch this, 67,600, okay, is equal to, let's get 80 squared. 80 squared will give you 6,400 plus, let's get q squared, q all squared, minus 2 times 80 times q. 2 times 80 is 160, so it becomes 160 times q. So you have this. Then cosine of 130, cos 130, the value in two decimal place is minus 0.64. Let's use 4 decimal places. If we use 4 decimal places, this becomes minus 0.6428. 6428 approximately in 4 decimal places. Okay, make sure your calculator is in degrees. You punch this, you have this value. Now proceeding with our solving, this becomes 67,600 is equal to 6,400 plus q squared. We have this as q vector q squared minus, or that becomes plus, I think. So what we do is just take minus 160 multiplied by minus 0.6428. So let's get that. So if you do minus 160 multiplied by minus 0.6428, you have your answer as plus 102.848. Don't forget you have a q here. So I'll bring in the q this way. So I'll have this plus 102.848, then q. So I have this. Alright, so my next task is that if I look at this, I want to get q. This looks like a quadratic equation. So I have to arrange this as a quadratic form. My before I do this, my first task will be bring this value over here. If I bring it over here, I'm left with 0. So 0 will be equal to, it becomes this one here, 6,400. This man comes here, becomes a negative, all right? From the left hand side comes to the right hand side, becomes minus 67,600. This plus q squared, so plus this q squared, this, then plus 102.848 q. We have this. Okay. All right, working on this, we have that 0. So 0 is equal to, or 6,400 minus 67,600. That's about minus 61,200 plus q squared. So plus q, this one here, all squared. Okay, plus, so plus 102.848. Then we have q. So this becomes what we have here. Now this looks like a quadratic equation, but we have to arrange this in descending order. So we'll start with q squared first. All right, so rearranging this in form of a quadratic equation, we'll have that this is 0 is equal to, we'll start with the one with the highest power, which is q squared. That's vector q, that's q all squared, plus, we'll take the next one there, 102.848q, that's 102.848q, and then finally we now have our constant as minus 61,200. All right, so this now becomes a quadratic equation. Solving quadratically, right? From here we're having solving quadratically, quadratically. Now it depends on the method of quadratic equation you want to use. For me, I'll just go straight to using the calculator, right? For time's sake, I'll be going straight to using the calculator. And for us to use the calculator method, we need to get the value of A, B, C, so we can input into our calculator. For this question here, the value of A is simply the coefficient of q squared, which is 1. All right, so from here we can say that A is equal to 1. So A, it's equal to 1, which is the coefficient of q squared. Let's get B. B is simply equal to the coefficient of q, which in this case is 102.848. So B is equal to 102.848. And C is your constant. For this question, your constant is simply minus 61,200. Okay. Now let's input this value into our calculator to get the value of q. All right. So using calculator method, q it's equal to. Now I'll show you how to do this with a Casio calculator. All right. So the first thing, when you have your calculator here, the first thing you want to do is to click on mode, which is by your top right. If I click on mode, as you can see, number 5 you have equation. So I'll come to 5 and press 5 equation. Look at number 3. Number 3 is ax squared plus bx plus c equal to 0, which is your quadratic equation form. So I'll press 3 here. It gives you a. Recall that we said a is equal to 1, so I'll press 1 equal to, it moves over to b, and we already got our b as 102, so I'll type 102.848, so 0.848. This is the value of b. I'll press equal to, it goes over to c. We got c as minus 61,200. This was the value of c. Then press equal to, so you have this. Now press equal to again. You have the value of x1 as 102. You have the value of x. You have x1 as equal to 201.25. That means the first value of q is 201.25. Now don't forget that this was a vector. So this, the value of this is this. This was in meter per second. If you check the question, P and Q were in meter per second. So meter per second or let's see the second value. Of course, every quadratic equation would have two values, so I'll press equal to again. You can see your second value as minus 304 points in two decimal places. That would be 10. So minus 304.10. So or minus 304.10. Of course, again, in meter per second. So these are the two possible values of Q. Of course, we expect that Q would be a positive value, right? But Q, or the vector Q, is positive. All right, it should be a positive value. Of course, arrow was a positive value with magnitude 260 meter per second. P was a positive value with magnitude 8 meter per second. Q should also be positive. That means if I have one negative and one positive, would have that Q would be equal to the positive value. So with these two, my negative is 304. I'll leave out this one here and take the positive value, which is this, and that becomes 201.25 in meters per second. So this now becomes the value of Q. All right. So with this, we've got the value of Q. Going back to our initial question, let's look at the initial question there. In the initial question, we asked to find the magnitude of Q, which we've gotten this value as equal to 201.25 again in meters per second. We've solved the A part. Let's get the B part. The B part, or the II, says the angle between P and R. All right. Let's find the angle between P and R. From this diagram here, we're looking for the angle between P and R. Right. Let me take this one off a bit. So how do we solve for the angle between P and R? First things first, where would that angle be in this diagram? This is the value, this is the part of P, this side here, and this is for R. So the angle between P and R is simply this part here. Let's call the angle, let's call it phi. Okay, let's call it phi now. So phi, so you can see here, is the angle between P, which is this side, and then R, which is this side here. Alright, so we want to get the value of phi. What do we use? From here, we use the concept of sine rule. Okay, for sine rule, we have that it's so II, we call that II, right? Using sine rule, using um, using sine rule. So let's use sine rule. How does sine rule work? Well, it's quite simple. It's simply equal to a part. So we use this part here, which is r. So r all over sine of the angle facing it. That's r all over sine 130. All right, that becomes r all over sine of the angle facing this is 130. It's equal to, now considering the angle phi, it becomes q, it becomes this value of q all over sine of the angle facing it, which is this one here. All right, so it becomes q all over sine phi. All right, so let's get that. That's equal to the value of q all over sine of phi. Let's impute values here. If I impute values here, this would be equal to, what's the value of r again? We got the value of r from the question as 260. So that becomes 260 r all over sine 130 is equal to q. Again, we just got the value of q from the question here. The value of q, we had that as 201.25. All right, so let's impute that value there, 201.25. 201.25, that's q, all over sine of phi, in which phi is the angle between P and R. Now let's solve this. Of course, for this, our first step would be to cross multiply. So this times this, and then this times this. So that's equal to 260 multiplying sine phi, this into sine phi, this into sine phi is equal to, multiplying this with this one here, that becomes 201.25 multiplying sine 130, this into sine 130. So I have this. All right, let's get this solved. To get the value of phi, I'll first have to divide here and also divide here by the coefficient of sine phi, which is 260. Divide here also by 260. This cancels this. I have that sine of phi, it's equal to, let's impute this value. Now, I'll get my calculator and punch this. So if I punch 201.25 multiplied by sine 130 divided by 260. So I'm punching everything at once and my answer gives me about 0.59295929. So I have this. So basically, if you punch all of this, please get this and do this correctly. If you punch all of this correctly, right, your answer should give you this, all right, 0.5929. That will be your answer. All right, so to get the value of phi from here, obviously to get phi, I will take sine inverse. So phi becomes sine inverse of 0.5929. We get this. So phi will be equal to, if I take sine inverse, so sine inverse of 0.5929, punching this, my answer gives me about 36.36 degree. So phi, the angle between P and R, is equal to 36.36 degrees. That's your value. So basically, this becomes the answer to the question, all right? So going back to this, the angle between P and R, it's equal to 36.36 degrees. All right, so basically this is how we solve this particular question. All right, guys, so as usual, if you enjoyed this video, please do well to hit the like button. All right, don't forget to hit the like button, like this video. All right, leave a comment. For your comment, tell us if you enjoyed this video. All right, don't forget to also subscribe. If it's your first time here or if you're yet to subscribe, please do also subscribe to this channel and hit the bell icon so that you get notified whenever we upload new content. Finally, do all to share this video to your friends so that they can also learn. Also check out my website www.jonahemmanuel.com/courses to get any of the available courses, or you can also check out www.jonahemmanuel.com/books to get any of the available books. You can also join my channel membership to get access to exclusive contents for my channel members. All right, I'll leave a link to my website as well as to join my channel membership in the video description. All right, so thank you and see you in our next class.